This is going to be the first video in my series on classes and objects in Python. And I'm going to be working in the Spider integrated development environment, and this is a package that comes installed with the Anaconda platform. Now, you may have heard that everything in Python is an object. And these objects are built from classes, much like a house would be built from blueprints. Generally, to build an object in Python, all we do is execute a single line of code. So just like that, we have a string object. And this string object does everything we expect a string can do. Now, it does that because inside the string class somewhere in Python, there is a method or a function within a class defined, and it's called upper. But we're not really interested in the built-in methods. What we're interested in is how do you create your own custom classes. So let's go ahead and do that. And at the most basic level, we start with the keyword class, and then we give our class a name. And by convention, we generally use an uppercase letter to define our class names. To start, I'm just going to make a class that doesn't do anything, and let's see what that gets us. So when I run this file, I can start instantiating or creating instances of the user object from the class. As I mentioned, this one doesn't do anything, but what we get by default is a bunch of inherited special methods from the base class in Python called object. And I can see some of these by just calling dir on our user. Okay, so you can see that all of the special methods start and end with double underscores. All right, some people call these magic methods. Other people call them dunder methods. And we actually get more than what you can see here, but this will be enough for us to get our work done. Okay, so the first thing we want to do to actually make our class do something useful is to initialize it. We do that with the dunder method init. And this behaves much like a constructor does in other programming languages, but in Python we call it an initializer. Now, most methods that you create inside a class are going to have at least one argument, and it is a self-reference to the entire class. All right, an initializer is also going to define a base state for each object that we make. And so it's going to have a list of properties that all of our user objects should have. So maybe a username, maybe a password. We'll give it an email and a birthday. Okay, now I am setting default values for all of these properties, which will mean I can create empty objects and then assign values to them as I go along. Okay, so when I create a user, it's either going to be empty or it's going to have some or all of these properties passed in. As I pass them in, I need to once again use that self-reference so that all of these attributes are going to be available to the entire class. So to do this, we're just going to prepend the self keyword to each one of the passed in properties. So now we can initialize objects of the user class, and we can pass in some or all of these attributes. And so I'm just going to create a quick user out here at the module level, and I will pass in values. Okay, once we create our object, we can then access some of these attributes, and we do it just using the dot notation. And often enough, what people like to do is print an entire string representation of the object. So let's see what happens if I try to do that with our user instance. Okay, let's run this. So as you might expect, when we run our little script here, we get our value for the username and we get a value for the password. What you may not have expected is this string that we got by printing the object. And by default, the object representation is inherited from that base object class. And what it gives us is just a memory location of that object. And there are a few ways to actually get a string representation of our class. All right, if I just call it in the interactive shell, I get, you see, the same thing. Okay, so this is the repr method from the object class, and it's considered a formal string representation of our objects. We can get it by printing. Okay, once again, we get what we got when I ran the code, and this is the method string inherited from the object class. You can access it by calling string on the class or object, and also repr on the object. Okay, so right now there's no difference between the two, but in the next video, we are going to override the default inherited from the object class and make our informal and formal string representations of the user objects.